Welcome to The Explainer. Let's dive right into this because today we're looking at a completely invisible, highly urgent threat that is literally rising up right beneath our feet. We're talking about the ground beneath the world's river deltas. These are places where an outsized share of our global population, our irrigated agriculture, and our massive coastal megacities reside. Now, on the surface, these regions look incredibly water abundant, but beneath the surface, a silent crisis is unfolding, and it's called saltwater intrusion. As we're going to see today by digging into the groundbreaking work of Professor Dr. Kapileswar Mishra on the Saline Commons Compact, this is not just an environmental or a physical crisis. It is actually a profound legal failure.
So, to really grasp the sheer scale of the danger here, we've got to talk about a terrifying ratio, 1 to 40. This is known as the Gibbon-Herzberg relation, and it dictates the physics of unconfined coastal aquifers under hydrostatic equilibrium. Here's what that means in plain English. For every 1 single meter that we drain our freshwater aquifers above sea level, the heavier, denser salt water from the ocean surges upward by an astonishing 40 meters. 1 meter down, 40 meters up. It is a compounding physical threat that completely exploits a fatal flaw in our current legal defenses.
When you actually visualize this physics law mismatch, it's wild. You have this massive 40-meter upward draw of salt water happening underground. That creeping saline interface isn't just going to wait around for our laws to catch up, right? It's being actively driven by over-extraction, sea level rise, and subsidence. But the reason this physical reality turns into a catastrophic social and economic crisis is entirely because of how we manage it, or rather, how we completely fail to manage it.
Which brings us to Section 1, the physics law mismatch.
We're dealing with a highly dynamic, moving subterranean environment, but we're trying to govern it using static, terrestrial laws drawn on two-dimensional maps. Think about it this way. Trying to manage moving underground saltwater with static property rights is quite literally like trying to build a static fence on a moving ocean. The saline interface is this dynamic, three-dimensional boundary. It shifts around based on density contrasts and hydraulic gradients. And yet, our legal instruments just stay entirely static, tied to surface land borders, completely blind to the reality of the water moving right underneath them.
Part 2. Escaping the Commons Tragedy.
To fix a legal system that's this mismatched with reality, we first have to recognize that a deltaic aquifer is the ultimate high-stakes common pool resource. It suffers from subtractability, meaning the water I extract is no longer available to you, and it's super costly to try and exclude people from accessing it. For decades, we looked at these resources through the lens of Garrett Hardin's famous 1968 essay, The Tragedy of the Commons. Hardin essentially believed that without strict privatization or extreme centralized state control, these resources were doomed to inevitable ruin. But Nobel laureate Elinor Ostrom proved Hardin wrong. She proved that communities absolutely can self-organize durable, layered solutions without resorting to heavy top-down control. She called this polycentric governance. Basically, multiple semi-autonomous decision centers operating at different scales, from a local village all the way up to a transboundary commission.
Section 3, the Saline Commons Compact.
Building right on Ostrom's hopeful foundation, Professor Mishra proposes an incredibly innovative, modern legal shield to protect these vital water sources. He calls it the Saline Commons Compact. The architecture of this compact acts like a comprehensive funnel. You start with the theoretical foundations, Ostrom, Coase, the public trust doctrine, and those feed directly into a structured legal framework, which then outputs real-world comparative solutions. This isn't just academic theory. It is a highly practical, legally implementable design.
The compact operates as a dynamic mechanism divided into 3 specific tiers. Step 1 is Tier 1, the normative charter, which draws the actual battle lines based on science. Step 2 is Tier 2, the operational phase, deploying automated licensing and sensors. And Step 3 is Tier 3, the adjudicatory phase, which sets up a specialized tribunal for peacekeeping. Let's break these down real quick.
Okay, Tier 1, the Deltaic Aquifer Charter. This fundamentally rewrites the rules. First off, it legally redefines management boundaries based on actual hydrogeological water flow, which completely supersedes arbitrary political lines. Second, it creates a rebuttable presumption against any new large-volume extraction in coastal buffer zones. That means the burden of proof is actually on the commercial extractor to prove they won't cause harm, not on the local community to prove they will. And finally, it establishes a ring-fenced, intergenerational aquifer fund, financed right by the polluters themselves, to build a war chest for monitoring and recharging the aquifer for future generations.
Then we get to Tier 2, and honestly, this is nothing short of revolutionary. By introducing science-triggered adaptive licensing, we get legislated clauses that rely on continuous monitoring of electrical conductivity, which is basically just how salty the water is. If the sensors detect that salinity has crossed a specific calibrated threshold, abstraction permits are reduced automatically. No requirement for further adjudication. These are automated tripwires. It completely removes the discretionary, bureaucratic delays that usually cripple environmental enforcement.
But here's the catch. For Tier 2 to actually work, it requires a vital open data protocol. I mean, individual farmers can't fight an invisible threat if they don't even know it's there. By making salinity and abstraction data transparent and standardized, we overcome what economist Herbert Simon called bounded rationality. We lower the transaction costs, which, according to the Coase theorem, enables affected parties to actually bargain and manage resources efficiently. Transparent data is literally the intelligence sharing required to win this fight.
Finally, we hit Tier 3, the adjudicatory level. Because, let's be real, even with great rules and great data, disputes are going to happen. Tier 3 establishes a specialized, low-cost Delta Water and Salinity Tribunal. This provides a crucial accountability function. It ensures that vulnerable fishing and farming communities actually have a dedicated venue to resolve disputes over induced or transboundary salinization without being buried in massive legal fees or tied up in standard courts for decades.
Part 4. Real-World Delta Governance.
Now, what makes Professor Mishra's framework so compelling is that we don't have to imagine it from scratch. Fragments of this exact system already exist in the real world right now, just waiting to be unified. Take the Netherlands. Their Delta program is incredibly well-funded and insulated from short-term politics, but it has a weak subsurface salinity mandate. It desperately needs Tier 2's automatic triggers. Over in California, the SGMA has great local agency empowerment, but incomplete limits that could really benefit from Tier 1 integration. Vietnam recently passed strong water laws, but lacks the funded enforcement and data sharing of Tier 2. China has strong basin-scale rules, but lacks the local participation championed in Tier 1. And in the Ganges-Brahmaputra Delta, you've got a massive clash between the public trust doctrine and old private extraction rights, which perfectly highlights the need for Tier 3's adjudicatory tribunal. The Saline Commons Compact patches the specific structural holes, what Mishra calls jurisdictional mismatch, temporal myopia, and accountability failure, in every single one of these systems.
Section 5. Securing our freshwater future.
Look, we're not just talking about abstract legal theory here. This is about global climate resilience, environmental justice, and securing drinking water and agricultural stability for hundreds of millions of people living in these deltas. Which brings us to the most urgent question of all. The Saline interface is moving right now. That 1:40 physics ratio, it doesn't care about our political borders or our legal delays. We have the blueprint for polycentric governance, we have the sensor technology for automated triggers, and we have the economic theory to make it all work. The invisible threat is surging upward. So will our laws adapt before the freshwater runs out? Thank you for joining me on this explainer, and I hope this leaves you looking a little differently at the ground beneath your feet.